like I said, it should be a lot of review because this is a lot of algebra. And I would assume that you definitely got through this part last year. So hopefully it's not a real difficult section and fly right through it. So today we talk about distance and midpoint. That's why we did those problems at the end yesterday. Okay. When we talk about distance again, a distance always has to be positive, but basically it's just the length between 2 points. And it doesn't matter if it's on a coordinate plane, doesn't matter if it's on a number line. You can really do this however you want. And remember, if we have something here and they give us the endpoints of QP, it really doesn't matter if you think about it and do it from Q to P or from P to Q. It should still be the same distance, right? Basically, if I stand here and I walk this way and I get to my endpoint, but I walk backwards, it's still the same thing. It's the same amount. So you just have to remember that when you do this, distances are always positive. So this means, in a sense, anytime that I do a distance, I'm going to take the absolute value of it, of my answer. So this is why I can do the subtraction in either case. So a couple different ways that I can do this. I could do this on a number line. And if I do it on a number line, hopefully, when you see a number line, you realize that depending on how many spaces they give you, maybe you just count them out. Or you can always do the subtraction. And so, again, if we say, use the same two letters, Q and P, I have two options. I can just count them, right? What's the distance from Q to P? 1, 2, 3, 4, 5. Or I can do my subtraction. And again, it doesn't matter because whichever way that I do it, it should come out the same way because I'm going to take the absolute value of both. So -2 minus 3 is -5, but the absolute value, and this is two negatives together make one giant positive. So I get absolute value of +5. So those essentially are the same thing. Right? So again, I can do that with anything on a number line. And again, it doesn't matter which way I do it. I can just count them, whatever the easiest way is for you. But this leads us then, so this is if it's on a number line, or I can do the distance between any 2 points. And this would include like in space. So if I had just two random spots in space or on the coordinate plane. And this is probably where you've seen it the most, is on the coordinate plane. So when I'm talking about any two random points on a coordinate plane, I have these two basic points of x and y. But somehow we have to differentiate between those two, right? So we put these little numbers down here, and we call these little numbers what? Any idea? Not exponents. We've actually said this word before, just a little while ago when we were talking about lines. These are actually called little subscripts also. So this is x sub 1 and x sub 2. It just means that it's sub or below. Okay. So I'm doing this in general. I have two random points, and I'm differentiating those 2 points. In most cases, you'll be given actual numbers, and they'll give you some letters that say capital J is whatever its coordinates are, and so on and so forth. But if we have any two random points, there's a formula for this. Anybody remember what the formula for distance is? Okay, keep going.
Over X.
Nope,
I don't know.
that's to find the slope.
Oh, I don't know.
Anybody remember this? So d equals, d obviously is my distance, the square root of, big square root. I'm going to do the difference of the y's. And I'm going to do the difference of the x's. And I'm going to square them. Anybody remember this now?
No.
Still don't remember? And then the last thing that we're going to do is put a plus sign in between here. So this is what Coro is asking about. Now, here's the question. Think about this before you answer. Does it matter which way I do the y's? And if I do the y's in a certain way, meaning if I do y sub 1 first and then y sub 2, right? Do I have to do my x's that same way? Because when we did slope, like Lauren was talking about, the difference of the y's over the difference of the x's, we always wanted those subscripts to line up. But is that true in this case? Most of you said yes. And just for pure confusion, I would go ahead and do that too. But in all honesty, this doesn't matter. Why doesn't it matter? So honestly, I could do x of 2 minus x of 1 if I wanted. But again, most of you said yes. So I would go ahead and do that too, just so you don't get confused when you go back to slope. But why doesn't it matter in this case? They're squared. Exactly right. So if I would flip-flop these two and do it in the opposite order, I would just get the same number, but I'd get a different sign. So if it was positive, I'd get the negative number. And then, like Cameron said, if I square that, it doesn't matter what the answer is, right? If I square 4 or if I square negative 4, I still get 16. So it doesn't really matter. That makes sense? Okay. So, what's going to happen here? Then we'll be just giving some points. K is 4, negative 3. And R is negative 2, 7. So basically all I'm going to do is take all those numbers and stick them into the formula. Now the biggest thing that a lot of people forget to do is that they forget the radical at the end. So don't forget it. Alright? So D equals the square root of, what are my y's? Negative 3 minus 7. It's always got to be subtraction. So remember, this is a subtraction sign. It's not saying that necessarily this is a negative. If this is a negative, then I have to have two negatives back to back. And I'm going to put those inside parentheses and square it. Plus, now what are my x's? 4 minus, so here's the case. Now we have negative 2. I need both of those negatives in there. Now I just simplify. And this is what Cora was asking if you didn't hear this. Remember way back when we started doing pre-algebra even. We got done doing this in pre-algebra right now. PEMDAS, right? The order of operations says that I have to start out with my P's or my parentheses. And when I'm working with my parentheses, I'm always working inside out. So that's why I gotta go inside here and simplify and then do my E or my exponents. So what's negative 3 minus 7? Negative 10. Negative 10 squared. 100. Plus, what's 4 minus negative 2? 6. And 6, oh, I forgot the square. What's 6 squared? 36. So again, this is where a lot of people forget that radical sign. So don't forget the square root sign. D equals the square root of 136. Is that a perfect square? Is that one of those numbers that we just know about? I wouldn't think so, right? So, two different things that you can do. One, I can punch it in my calculator. Because as I just told Cora, does it make sense if somebody said, hey, go run the square root of 136 miles? Would you really know how much to run? Probably not, right? So if you punch this into your calculator and you get a decimal answer, you'd understand how much that would be, right? Anybody have their calculator out? So we say the square root of 136 is 11.6. So again, now, do I know that this is an exact answer? No, so I'm going to use these squiggly marks. And what does the squiggly marks mean? About, or approximately, right? So again, if somebody said, hey, go run 11.7 miles, most of you would say, forget it anyway, right? But at least you would understand that. And again, remember that this has to be a positive number. So if you ever come down to this point right here where this number is a negative, stop because you did something wrong. It's always got to be a positive number. Okay. Now again, if these points were given to us on a coordinate plane, you might take the time to at least visualize where they are. Or you can look at the coordinates, and if one of the coordinates are the same thing, like if my x's are the same number, then I would know that they're either across from each other or on top of each other. And then I might just plot them so I can count them out instead of actually doing the math. But the math will always work. And why we have to have this formula is when I'm talking about points, if I'm talking about this blue point up here and this purple point down here, see how they're not on they're on a straight line, but they're not on lines that are on my coordinates? I have no way of actually physically counting them from one point to the other. I have to have a formula. Okay? Do you want to see another, or do another one of these on your own? Yes. So, we say that t is 0, -4, and m is -2, -6. So if you want to try another one, try another one. How do we do? Maybe I did it wrong. Anybody else get 2.8?
Wait, what one did this to?
Okay, so did you at least get the square root of 8?
Yeah.
In all actuality now, if you're going to leave it as a radical, we should try to do what we did in that first chapter. And reduce it, right? So this would have then turned into what? 2 square root of 2. So again, if you're going to leave it as a radical, go ahead and reduce it down. Everybody okay? Anybody need more of those? So from there then we transition into midpoint. What does the midpoint of something mean to you? Yeah?
What should I test to get that?
See this right here? Oh. You gotta hit second first because it's in the folder.
Okay.
Yep. Then hit top of the can. Thank you. What's midpoint? What does it mean? Just think about the word. The middle, right? Okay? So we're going to talk about the midpoint. And we're going to do this in two versions too. The midpoint can be either on a number line, or it can be on, or it can be any random point again. Okay? So this is going to be one of those things that you're going to use, or you could use in a proof. All right? So they come and actually give you the definition of a midpoint. This would be in the back of your book in the glossary or just in general. So the definition of the midpoint. The midpoint of, and then, the midpoint M of PQ is the point between P and Q that PM is equal to MQ. Now again, a lot of these theorems, when we get into the following chapters and postulates and definitions, will have all these words. A lot of people don't like words. A lot of people like to have something that they can actually see. So they're saying if I have P and Q here, my midpoint has to be a point that's right in the middle. And then they would take the time to say that that's where PM is equal to MQ. And again, I apologize for not saying this yesterday, but a way of showing everybody that there's no argument that M is the midpoint is to come back and have little slashes there. And with those little slashes, it automatically says that M is a midpoint. There's no argument. So we actually have two formulas then. And what is a midpoint on a number line? So again, if we have our number line, we have our little slashes, we have our numbers down here. I could go through and just kind of tally it off one by one, you know, as long as I go from here to here on both sides, I could really zero in on the middle, or I can do some math to it. So again, if we're given 2 points, and we call it Z and T, it doesn't matter. I could go through, and like I said, you could start at each one and just move one at a time and see where I meet in the middle. And it's okay if it's a half. So I'm guesstimating that my midpoint is right there, which would be a -1/2. But there's got to be a formula for me to be able to do this, okay? So what am I really doing between those 2 points? What mathematical, I guess, problem would I be doing there? I'm taking the what of it between those two. The what?
Yeah.
The average of those two. So if I find my two numbers, -4, if I take the average of anything, what do I do with them? Add them up and divide by 2. So -4 plus 3, and then we divide by 2. Why divide by 2? That's how many we took and added up together, right? So -4 plus 3 is -1/2, and we get our -1/2. So our midpoint formula on the number line, we could say, if we know any 2 points, A and B, we're going to take A plus B and divide it by 2. So this would be my general formula again. as long as we know that this is saying for any numbers A and B. That formula would work. And again, now, are you going to use this that much? Probably not anymore. This would have been more of a pre-algebra or a algebra thing because this is kind of the introduction with the number line. But does that make sense, what we're saying there? So again now, if we switched gears and made a big number line, and when we have a big number line, we just really want to show 0, and then we could say this is negative 47, and this is 37. And you're asked to find the midpoint of that. Well, you probably wouldn't want to take the time to, like tick off one by one, right? So then that's where the formula comes into play. And again, it doesn't really matter how you do it. If you would do it the other way, meaning starting on the right and adding the other way, it would still work, right? Because we're adding, and if they have different signs, we just subtract anyway. So what's negative 47 plus 37? Negative what? Negative 10. And so we get negative 10 over 2, or what? Negative 5. So does that make sense? If we started ticking these off, we'd get to negative 5 to be in the middle? Yeah, it makes sense. All right. So again, that is if we have the problem where it's just on a number line. Now we need to have a way to find it if it's any two random points again. Meaning if it's on our coordinate plane or if it's just in space or whatever it happens to be. So now we have the midpoint of any 2 points. And again, we're still going to use that generic points of x of 1, y sub 1, and then x of 2, y sub 2. So what do you think for this? Well, again, if I came over here to my coordinate plane and I use the blue dot again and the purple dot, I still want to find the what between those two dots. What'd you say earlier, Dave?
The average.
The average. So I'm still looking for the average. So, but what you have to realize here, and this is really important, and I'm kind of picky about this, my answer has to be a what? Yeah. My answer is a point or an ordered pair, x1. So at the end of every single midpoint problem, you better make sure that you write it as a point. So, big ordered pair here because we need more space. But now we're back to what Dave said earlier. We just want to find the average. But I want to find the average of my x's. So again, two things, I add them together and I divide by 2. And if you want to put the little subscripts, we can write x of 1 and x of 2. And then big comma, because this is really my x coordinate of my midpoint. And then I do the y's. Now, should we do this in the same order that we did the x's? Yeah, you really should. So that's where the distance formula, when we had it up there earlier, you really didn't have to do the order the same way. But everything else pretty much has to, so I would just do the distance formula that way too. Then you don't get confused. Okay, so if we use this example up here, what's this point way up here? If this is a regular coordinate plane, it'd be what? 2, what? 8, 10, 12. 2, 12. So we want to find the midpoint between 2, 12, and my purple one over here is what? Negative 6, 0. Alright, so we got our 2 points. Now we're trying to find the midpoint between them. So, what are my x's?
2 and negative 6.
2 plus negative 6. And then we divide by 2. Because again, we're adding two things together. big comma. Because I used the 2 first, which y should I use first? We're going to use 12, the same y as we started with the same x. 12 plus 0 divided by 2. And so my answer is that math simplified. So what's 2 plus negative 6? Negative 4 divided by 2? Negative 2. And 12 divided by 2 is 6. So if we come back to our coordinate plane over here, how would I plot that dot? Where would I go? Which way is negative 2, 6? Left 2, up 6, right? Does that look like it's in between those two? Yeah, it looks like it works. Perfect, right? Nice, huh? Another one of these? Using the formula. One more little thing. So, any questions so far on those two? So the next thing that we do or introduce here is actually something that's going to be kind of important. And we call this a segment bisector. So now you got to start thinking. What's the word bisector mean to you? Any idea? If you bisect something, what do you do to it? Cut it where? Cut it in half. Okay? So essentially, a segment bisector is a what? If I was right, and this means to cut something in half, and then we cut a segment in half, essentially it's the same thing as what?
Midpoint.
The midpoint, right? So this term right here is the same thing as a midpoint. So, how do I definitely tell this? Again, if they give me A, B, and they put C in the middle, I have no idea if that's truly in the middle, right? The only way that I would is if I got a ruler out or a yardstick and measured it out, or if I come back and I put these two things here. If I put the little slashes there, it's saying that C bisected that segment AB, or it is the midpoint. And this could be a line, this could be a segment, so, or it could be a point, it could be a plane. So besides having a point there, I could have drawn some line right here and said, this is line M. But again, as long as I put those two little slashes there, then I would say M, line M, is a segment bisector because it bisected my segment, which caused the midpoint to occur. And so then we could come back and put C here. Even if they didn't put C there, we could put C there because it is now the midpoint because of that line making it. Okay? Make sense? Questions here? So again, a lot of this is going to be real straightforward today. You might have to do some reading some story problems and such, but the problems will give you something like this, right? Find the coordinates of D if negative 6, 4 is the midpoint of DF, and F has the coordinates of negative 5, negative 3. So I want to show you this one right here quick because this is actually doing what? This would actually be going backwards. Okay? It says D, find the coordinates of D if E is the midpoint. So now, if I know that I have the midpoint, I'm looking for the pieces here that will help me get to this midpoint. So my normal formula is this, x plus x over 2 and y plus y over 2. But right now, I only have one of those. I've already got the answer. So this is going to say x plus, what is the x of one of my endpoints? -5 all over 2. And then the other part is y plus -3 over 2. And so how do I solve this? I take each one of those coordinates and set it equal to this part over here that goes along with it. So the x is -6, the y is 4. So when I want to solve for what is my other endpoint, I would say x, and I can simplify this by just writing x minus 5 over 2 and setting it equal to my x. And then I'm going to do the same thing for my y. So 4 is equal to y minus 3 all over 2. And how do I solve for each of these? How do I get my x all by itself here? I'm going to multiply by 2, right? So x minus 5 equals -12. And what's x? Add 5 to this side is -7. Over here, 4 times 2 is 8. How do I get y alone? Add 3. So the other endpoint then is -7, 11. So this one's just the same process, you're just finding a different piece of it, in a sense. Instead of having the whole thing and looking for the midpoint, you already have the midpoint and you're going back and trying to find one of the endpoints. So those are the ones that kind of get some people, but again, just set it up and do basic algebra to it. Don't get freaked out about it. Okay? Any other questions?